So today's lesson is kind of like yesterday's lesson, but we're not going to do any graphing. You're like, well, Mr. Hamrick, how is it like yesterday's? Because all we did yesterday's lesson was graph. Well, not really. We put stuff in slope-intercept form, right? So we're going to actually not do that today. I'm looking at what we're doing. I'll just show you. This is something that I get people that complain to me every once in a while, me saying this all the time, but I just can't help it. And I try not to say it, but I don't know, for some reason, I don't know if it helps, probably doesn't help, but at least it gets you thinking like, oh yeah, maybe I did learn this before. Yes, ma'am. We are going to plug some stuff in, absolutely, okay? And we will talk about that here in a sec. So what we're going to do, we're not going to solve graphically like we did in 3-1. We are going to solve algebraically. And when I say a couple of these words, actually I think yesterday I even mentioned those words. There were two words that I mentioned that we use when we solve these things algebraically, when we solve systems of equations algebraically. Do you remember what those two words were? First one starts with an S. And U. Substitution. Very good. I knew somebody would get that. Oh, did you? And elimination. Yeah. Did you learn this last year at Red Lion? Yeah. Okay, good. With Miss Pango? Good. Do you know I shot her wedding? Yeah. Did I tell you? Oh, she told you? Yeah. Maybe one day I'll show you the pictures.
I have one.
You got one? Okay. So anyway, substitution, elimination. Raise the hands. Have you heard of that before, substitution and elimination? Okay. All right, good. Not everybody, but some. That's okay. If you didn't hear it, I'm not expecting you to just be able to do the problem right now without me teaching. I'm going to teach it to you as if you never heard it before. Is that good? Yeah. So let me put a system of equations down. And these are going to be right under each other, which I think is a good idea. And a lot of times you'll see they'll put this little brace on the outside to mean that they are together, they go together. So this x in the first equation will be the same value as the x in the second equation. Does that make sense? So if I get x equals 2, that means 2 is going to work in this for this x, and 2 is going to be this x right here. If I get 3, for the y is going to be 3 here, and y will also be 3 here. Make sense? All right. So that's kind of what the brace does. It kind of keeps them together. It means they do have some relationships. Now, we could use the way we did yesterday. We could graph it, find out where they intersect, and that's going to be your x and your y. But sometimes, as you saw when we went over that one homework, when they have fractions in there, sometimes it's not going to match up. Like what if the one we graphed before, it did intersect right on that graph line, right where those intersections graph. So we're pretty close to being 100% sure that was our answer. But what if it intersect like in the middle of one of those graph lines? Is there any way to accurately guess where it intersects? There's really not. It could be a half, it could be a third. Those blocks are so small, how in the world could you tell? There's no way you could be accurate. Would you agree? Yes. This way, you can be 100% accurate, right? So whether it comes out to some kind of a crazy fraction, and they might. I think at first, actually the second example does come out to it's not that crazy, but it does come out to a fraction. This one comes out right as with both integers, the x and y being both integers. So what we're going to do, we are going to do this first way of doing this thing right now is called substitution. This one is tailor-made for you to use substitution. When do we get out of this class? 05? Okay, I got 15 minutes. All right, so this is perfect for substitution. We've done substitutions before, right? Like if I said evaluate 3x plus 2 if x equals, -2. This is substitution. What do you do with that x, that -2? Jaslyn, what'd you say? What word did you use? Plug it in. That's right. Okay. And then math teachers say that all the time. You may not see that expression in a math book, but teachers always say it. You plug it in. You take this -2 and you replace it. You substitute it, okay? Everybody hear that word? You substitute it in for the x. So check out this. This is kind of the same thing. Again, this is tailor-made for you because they tell you what y is, kind of. They tell you what y is in terms of x, meaning x is part of our answer here. So they kind of tell you what y is. So what are you going to take? This is the value of y. What are you going to do with that value? You're going to plug it in to the y in the other equation. Remember, both y's are the same, right? So if both y's are the same, I can take what y is equal to down here and plug it into the y in the first one. Why would I want to do that? Because once I put an x minus 8 in here, guess what I have on this equation? I got all x's, right? Remember we talked about yesterday? I think it was you guys. If you have one variable, you only need the one equation. If you have two variables, you need how many equations? Two. If you have three variables, three equations. It was in here, I talked about that, right? Okay. So we got two variables, so you have to have two equations. You could not solve for x and y if you only had that first equation. All right? We do have a second equation, and they tell you straight up, y is equal to this. So I'm going to take this, plug it in for y, and let's finish it up. Let's move this stuff. I don't need that anymore. Let's get rid of that dot. Okay. So what we're going to do is we're going to rewrite that first equation, but instead of y, what are we putting in for y? We're putting in x minus 8. All right, so let's just write that first equation again. 3x, instead of plus y, it's what? Plus, nobody's talking to me? X minus 8, thank you. All right, equals negative 20. See, this was the y, wasn't it? Isn't that the same exact equation as the first one? Right, except we just replaced what y was equal to in for y. And now I got one equation, I got one variable. You know, like Mr. Hamrick, I got two variables, got an x here and an x here, but it's the same variable, right? So that's what I mean by only one variable. So now let's just do a little bit of algebra, algebra 1 stuff. 3x plus x is 4x. Let's do this. Let's add an 8 to both sides. We'll just do it right now before we bring everything down. You okay doing that? What's that going to be? Negative 12? Yeah? Divide by 4. Divide by 4. X is negative 3. Don't circle it just yet, because how are we going to write our answer? As an ordered pair. Why do we write our answer as an ordered pair? Because it's the point of intersection between those two lines. Does that make sense? All right, so I'm not going to circle it just yet. I'll circle it when I write it as an ordered pair. Now, I found what x was, but now what do I have to find? I got to find y. If you wanted, you could take that negative 3 and put it back into the first equation and then solve for y. I probably wouldn't, because look, y is already by itself right here, isn't it? That's the easier one to do. You could put it back into either one. It doesn't matter. But I'm going to pick the one that's easiest. Would you agree? Yeah. Okay, just because I'm a teacher doesn't mean I want to do things the hard way. I want to do things the easy way. So I'm going to take that and put it in for the x right here. So y equals, instead of x minus 8, what am I going to put? Negative 3 minus 8. And y equals negative 11. So those are my two answers. But how do I write my answer, though? I write it as an what? Ordered pair. So I'm going to write negative 3 first, because that's the x. Then negative 11 second, because that's my y. Put it in parentheses. Okay, everybody got that? Ordered pair should always be in parentheses, and you can circle it, and then that's your answer. That was pretty simple. They started off with a really easy one. Okay, they're not always going to be that easy, but let's move on. We're going to do another substitution before we worry about elimination. Everybody got that down? Okay, I'm going to move it up. Everybody has it? Let's do another one. This is example 2. 2x minus y equals 8. And then 4x plus 3. Oh, what happened there? 4x plus 3y equals 2. All right. And you can put that little brace there. You don't need it, but it just means they go together. So we got to do some substitution. Now, on the other one, they told you exactly what y was equal to. They had y by itself, didn't they? Y equals boom, whatever. This one, they don't really do that, do they? But you could solve for y, or you could solve for x on either one of these equations. It does not matter. All right, I got 4 possibilities. I could solve for this y right here. I could solve for this, this x right here. I could solve for that y right here. Or I could solve for this bottom x, or I could solve for that bottom y. It does not matter which one you pick. It'll still work out in the end. But I want to do things the easiest way. So what do you think would be the easiest of those letters to solve for? The top x and y or the bottom x and y? The top what? I would say the top y. I think that would be the easiest one to solve for. Is everybody in agreement on that? Do you have to solve for that y? No, you don't. But I just think it's a little bit easier to solve for. You might be able to do it in your head. We're Algebra 2. Let's think at doing this in our head. I could take this minus y, move it over here to get it by itself, right, and make it positive. And then I could take this 8 and move it over here. So what would I get? I would get y equals what? 2x minus 8. Can you do that in your head? If not, write down the steps. That's fine. But that's what you should get. Now, that's only one extra step than what we did on the first example, isn't it? So I had to get y by itself, or I had to get x by itself. It does not matter which one. So now what I can do is take what y is equal to and put it into this equation right here. Put it into that one. Now, if you put it into this one, everything's just going to cancel out and go to 0. So don't put it back into the original one where you got this. You got to put it into the other one. Okay? So let's write this out. Just rewrite the second equation, but instead of putting a y, what are we going to replace that y with? 2x minus 8. Good. All right. Let's do it. So we got 4x plus 3 times y. So I'm going to put a parentheses because I'm multiplying it by 2 things. All right, so it's very important that you put a parentheses there. 3 times y. Y is 2x minus 8, so I put a 2x minus 8 right there. Just finish off the rest of the equation. There's my 4x, there's my 3y, correct? Equals what? 2. And now I got one equation and one variable. Now I can solve for that variable. Just a little bit of Algebra 1 stuff. Let's do it kind of quick. 4x plus 6x minus 24. Oh, come on, pen, help me out here. 24 equals 2. Add their like terms, that's 10x. Add a 24 to both sides, that's 26. Divide by 10. Now, I'm not going to write it as a decimal. I always like fractions, okay? There are times where we use decimals. For the most part, I would say we're going to put everything as a fraction. So what goes into both of these? 2 does. 2 goes into that 5 times. 2 goes into that, what? How many? 13 times. So 13 over 5. Now, if I wanted to graph that, you could write it as, what, 2 3/5. I'm fine with you keeping it 13 over 5. So that's half of our answer. How do I find the other half of the answer? Take that 13/5 and put it where? In for the x. I could put it in for this x here or this x here. This has already got y equals, all right, I already got y by itself, so I'm going to put it back into this. So I'm going to take this one right here and rewrite it, y equals 2. I'm going to put it over 1. Why am I going to put it over 1? Because I'm going to multiply it by a fraction. This is why I don't really want to use 2 3/5. I'm going to use 13/5. So 2 times 13/5, then what? Minus 8. What do I get here? 2 times 13 is 26/5 minus, now what am I going to do here? 8 over 1? No, I want it over 5, don't I? Because I got to add or subtract fractions. So I need a common denominator. So it's going to be 5. So 8 times 5 is what? 40. Would you agree? 40 over 5 is the same thing as 8? I know I'm talking a little fast here because I'm looking at the clock, okay? But you can always go back and watch the video and slow it. Well, you can pause it, you know, think about it a little bit more. So what's that going to give you? Negative, what's that, 14? Yeah? Over what? 5. So that's what y is equal to. But how do I write my final answer? As an what? Ordered pair. So I put the x first, which is 13 over 5. Then I put the y in, which is negative 14 over 5. Is there any way that you would have probably guessed, I don't know, maybe you would have guessed a half, right? Because it's just a half, isn't it? Right? Well, actually, no, not necessarily. But you could see where this would be difficult to be able to find the exact answer by graphing, right? There's just no way you're going to get 2 3/5. Would you ever guess that, if it went in between those graph lines, that it's going to be 3/5, which is like 6/10? There's no way. Nobody's going to guess that, right? So this is a way that we can find it exactly. All right, so we've done substitution. I really wanted to, but I only got like 4 minutes left. So I don't think, let's just do one. We can do one example. I'm not going to finish the lesson. I was hoping to. Did I make this a B, a part B? Did anybody look at the lesson plans? Probably not. Let me just double check. 3, 2, oh, I did. I did give you A and B. Good. So tomorrow I can just teach. I'll just stop there. Okay, we'll stop at substitution today, and then I'll give you the elimination stuff tomorrow. I think, though, I still gave you an assignment, I believe. 7 to 14. So I believe all of those say, oops, my pen. Anybody have their book out? Oh, is it? Okay, let's just do 7 to 10. So I'm going to revise what I put on the lesson plans. So we're going to do section 3-2A. What page is that? Page what? 115? Okay. And tell me the numbers one more time. 7 to 10? Okay. So 7 to 10 should be all substitution. All right, so just do 7 to 10. I think I said 7 to, again, my memory's horrible. I just looked at it 2 seconds ago. I said 7 to 14, right. But let's just do 7 to 10, all right? And then we'll do the elimination ones tomorrow. We good? I mean, you could do all 7 to 14, but do them all by substitution. But I want you to do them both ways, just so you have good practice both ways, all right? All right, that's it.